Hi, welcome to a solution video of International A-Level Mathematics P2 in January 2021. Problem 1. Fx equals to x to the power of 4 plus ax cubed minus 3x squared plus bx plus 5, where a and b are constant. When fx is divided by x plus 1, the remainder is 4. Show that a plus b equals to minus 1. Here is fx. If we divide fx by x plus 1, that means we have to substitute x equals to -1 into fx. So then we will have f of -1, which is -1 to the power of 4 plus a times -1 cubed minus 3 squared plus b times -1 plus 5. And since the remainder is 4, that means f of -1 will be 4. So we can put 4 here and simplify the right hand side. This one will be 1 minus a minus 3 minus b plus 5. And this one will be 3 minus a minus b equals to 4. And then we rearrange it. It will be a plus b equals to -1. Problem B. When fx is divided by x minus 2, the remainder is -23. We have to find the values of a and b. So if we divide by x minus 2, we have to substitute 2 into fx. So f2 will be 2 to the power of 4 plus a times 2 cubed minus 3 times 2 squared plus 2b plus 5. And since the remainder is -23, so that means f2 will be -23. So we can put -23 here and simplify the right hand side. This one will be 16 plus 8a minus 12 plus 2b plus 5. This one will be 9 plus 8a plus 2b equals to -23. So 8a plus 2b will be -32. So now we've got two equations, which are this one and this one. Then we can simplify this equation to be 4a plus b equals to -16. Then we can consider this equation as the first equation and this one as the second equation. To solve simultaneous equation, we can just use equation 2, subtract equation 1. So this one will be 3a equals to -15. So a is -5 and we find b, -5 plus b equals to -1, so b is 4. So the answers are a equals to -5 and b equals to 4. Question 2. A curve has equation y equals to x cubed minus x squared minus 16x plus 2. Use calculus, find the x-coordinates of the stationary points of the curve. You can see that at the stationary points, the gradient is 0. So first we have to find the gradient. To find the gradient of the curve, we can differentiate it. So the gradient will be dy by dx, which is d by dx of x cubed minus x squared minus 16x plus 2, which is 3x squared minus 2x minus 16. And then we equate this gradient to 0. To solve this equation, this one is a quadratic equation. So it will be 3x and x equals to 0. 8 and 2 here, plus here is minus. Now we have two terms multiply each other and get 0. That means either one of them has to be 0. So we've got two possibilities, which are 3x minus 8 equals 0 or x plus 2 equals 0. That means x will be 8/3 or -2. So these are the x-coordinates of the stationary points. So to just define the nature of stationary points, we have to use second derivative, which is d squared y by dx squared. That means we differentiate the previous differentiation, which is 3x squared minus 2x minus 16. And the answer is 6x minus 2. That's the second derivative. And since we have two values of x, which are x equals to 8/2 and x equals to -2. So we substitute these values of x one at a time into the second derivative. So this one will be d squared y by dx squared when x equals to 8/2, which is 6 times 8/2 minus 2, which is 14. If the second derivative is greater than 0, that means x equals to 8/2 is a minimum value. And then we substitute x equals to 2 into the second derivative. So this one will be 6 times -2 minus 2, which is -14, which is less than 0. So that means x equals to -2 is a maximum value. Problem 3. Solve 7 to the power of x plus 2 equals 3. Give your answer in the form x equals to log a base 7, where a is a rational number in its simplest form. So to solve this one, we have 7x plus 2 equals 3. 7 to the power of x plus 2 is 7 to the power of x times 7 squared, which is equals 3. And we can move 7 squared to the right hand side. So this one, x 3, 7 squared. Since we have to give our answer into the form of log base 7, so we are going to take log base 7 to both sides of equation. This one will be log 7 to the power of x base 7 equals to log 3 over 7 squared base 7 here. According to log property, we can move x here, and log 7 base 7 is 1. So that's why we have only x on the left hand side. Then for this one, we've got log 3 over 49 base 7. This term is a rational number in its simplest form, so this is the answer. Next, we have to use laws of logarithms to solve this equation. In this case, everything is in terms of log base 2. We better change 1 in terms of log base 2 too. And according to log property, log a base a equals to 1. That means we can change 1 to log 2 base 2. So log 2 base 2 here. Plus, another log property is when you have log plus each other like this, you can just change it to log of a times b like this. For this one, we're going to apply this property to change it to be a product of y and y plus 4. So this one will be log base 2 of y times y plus 4 equals to log 5 minus y base 2. And then you apply the same property to these terms. So it will be log 2y times y plus 4 base 2, which is log 5 minus y base 2. It has to be log of the whole thing here. And on this side, we have a single log term here. So that means the things inside the logs are the same. 2y times y plus 4 will be 5 minus y. Now without log, we can simplify this equation and solve for y. This one will be 2y squared plus 8y equals to 5 minus y. And we move everything to the left hand side. So we have 2y squared plus 9y minus 5 equals 0. So we factorize it. It will be 2y minus 1 times y plus 5. So y will be 1/2 or -5. And since inside a log it cannot be 0, so that y cannot be 0, so the only answer is 1/2. Here is problem 4. Find the first 3 terms in ascending powers of x of the binomial expansion of 2 plus px to the power of 6, where p is a constant. Give each term in simplest form. So to expand this term by using binomial expansion, we write out the formula. So then we can expand this term. The first term will be 6 choose 0. A, which is 2 to the power of 6. B is px to the power of 0. Plus 6 choose 1. A to the power of n minus 1 is 2 to the power of 5. Px to the power of 1. Plus 6 choose 2. 2 to the power of 4. Px squared. And then we simplify this term. 6 choose 0 and px to the power of 0. They are 1. So the first term will be 2 to the power of 6 plus 6 choose 1 is 6. 2 to the power of 5 is 32 times px plus 6 choose 2 is 15 times 16. P squared x squared. 2 to the power of 6 is 64 plus 192 px and plus 240 p squared x squared. And this is the first three terms of the expansion of 2 plus px to the power of 6. And the next part is the coefficient of x squared in this expansion is negative 3 over 4. We have to find the possible values of p. So here is the expansion of 2 plus px to the power of 6 from the previous problem. And now we have to multiply 3 minus 1/2 x to this expansion, which is this term. And then we have to focus on the coefficient of x squared. Now we look for the terms that are going to multiply each other and get x squared, which are this term and this term, and then this term and this term. The x squared terms are 3 times 240 p squared x squared minus 1/2 times 192 px squared. We simplify this term, so it will be 720 p squared x squared minus 96 px squared. And we can simplify this term by making it to 720 p squared minus 96 p of x squared. And since the problem said the coefficient of x squared is negative 3 over 4, 720 p squared minus 96p equals to negative 3 over 4. So we simplify this term, and it will be 2880 p squared minus 384p plus 3 equals 0. So you simplify these terms by factorizing 3 out. So it will be 960 p squared minus 128p plus 1 equals 0. Then we can factorize this to two brackets. The first one will be 120p minus 1 times 8p minus 1. So p will be 1 over 120 or 1 over 8. These are the two possible values of p. Here is problem 5. Use algebra to prove that for all x is greater than or equals 0, 3x plus 1 is greater than or equals to 2 square root 3x. So to solve this one, we have to write down some plan. I'm going to start with 3x plus 1 is greater than or equals to 2 square root 3x. And then we can move 2 square root 3x to the left-hand side. It will be 3x minus 2 plus 1. And you can see this term, 3x, we can change the form to be square root 3x squared and then minus 2 square root 3x plus 1. From this term, you can see that we have a quadratic expression. That means we can factorize it into two brackets. Square root 3x minus 1 times square root 3x minus 1, which is greater than or equals 0. So this term, we can rewrite it as square root 3x minus 1 squared, and is greater than or equals to 0. Now we can stop because we see some fact here. This one is 100% correct because every square term has to be greater than or equals 0. And then we are going to start our proof from this fact. So here in our proof from square root 3x minus 1 squared, which is greater than or equals 0. This is the fact. That's why you can start your proof here. And then you copy the plan from the last line to the first line. The next line will be square root 3x minus 1 times square root 3x minus 1, which is greater than or equals 0. And then we copy the next line, which is this one. It will be square root 3x squared minus 2 times square root 3x minus 1 plus 1 is greater than or equals 0, which is 3x minus 2 square root 3x plus 1 greater than or equals 0. And then we move 2 square root 3x to the right hand side. It will be 3x plus 1 is greater than or equals to 2 square root 3x. And then you erase all of this plan because you don't have to show them. Just show only this part. The next part of problem 5 is show that the following statement is not true. The sum of 3 consecutive prime numbers is always a multiple of 5. Since we just have to show that it's not true, so we can prove it by finding a counterexample. For example, we can just use 5, 7, and 11. If you add them together, it would be 5 plus 7 plus 11, which is 23. And you can see that 23 is not a multiple of 5, so this statement is not true.